When I first started putting this together, I was pretty thoroughly engaged with it, and turning on a camera is not really a thing I was going to do. I've really found I enjoy it, just recording this stuff as I do it. Maybe there's a slight touch of megalomania to it. I don't know. It's just lovely to be able to record how this happened. So I didn't show any of the sockets though. I was so heavily engaged in just getting by. But I've got this one socket left to go. It just arrived. And so we'll put this fellow in on camera. Probably the trickiest socket of the lot too. Good job, I've had plenty of practice. So this is the socket for AGNUS. It's a PLCC. Blah 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 that stands for. I can't recall. So we need to get this in the right way, like the other socket, so that it properly indicates the orientation of the chip. I think the socket's pretty agnostic, like these ones are. But there's this corner's missing off it, there's a corner missing off there, and there's an arrow here pointing to pin 1, and there's pin 1. So there can be no doubt that it goes in there like that. That's right, there can be no doubt. Yep. And so we'll go with the usual thing I've been doing for sockets, and that is to just tack them down with a bit of blue tack. And because we can line this up, we will. We can rotate a little bit on its pins. We'll give it a little nudge, then we'll very carefully turn the board upside down. We don't want to bump it. It's by no means the most sticky outy thing. That's all of the edge connectors at this stage. And then my soldering iron is confused. I probably should have bought, or should buy, a nice one instead of whatever I can get cheaply, but it's actually a good iron. And these ones with where the temperature sensor and the element and the tip are all bonded in one package, while a little bit wasteful, though not on a planetary scale, really do have an advantage in that there's a less of a lag, because there's less thermal resistance between the element and the tip, and I like it. So I'm going to solder this in. I'm going to pick a trace that has a limited amount of copper attached to it on the board. Got the iron set to 370, down from some of the higher temperatures I had for the bulkier leads and the bigger ground planes. Now I'm going to be careful. I don't want to put this down and bump it. And what I didn't do is check the socket. The socket is mint. It's tacked down. There's no sign that it's These 3M sockets are in 2 parts, which, yeah, I'm going to put the whole weight of the board on that and just remelt these joints Nearly lost my solder off the bench. Alright, let's have another look at that. Yeah. Yeah, that's better. I think the thing to do with this next time will be to put a piece of polystyrene or something under it and make sure it's got real positive pressure on it rather than just being held in place by some blue tack. Even this corner here, and we'll do the same over in this corner. Just the solder's on there now. Takes a minimum amount of heat to to remelt it. If I had a third hand, I'd do it all in one shot, but I'd also be a mutant. Ooh, that is snug. Yep. All those gaps are nicely closed up. Except maybe that front one. That's interesting. It's almost like the piece in the middle is designed to float a little bit. I'll just double check that theory by remelting this joint. Also conscious of not... Yeah, that's it. All the pins are still in the right spots. I'm conscious of the fact that if I squash it in and then let it go, it could try and drag the pins back down through the socket as well. But that's a nice fit. I'm quite happy with that. One paranoia check. Pin 1. Yep, all right. It is all correct. And now begins the work of running around the edge of this. Clean iron's a fine thing. I found with this soldering iron and this flux at 370, the flux tends not to burn. At high temperatures, the flux will often end up... I need my readers. Blind as a bat. I used to be way blinder, and so I think I'm probably far too inclined to put up with things being a bit blurry. I had laser surgery about 10 years ago. That was quite effective. It was extremely effective. In fact, for some years I didn't wear glasses at all. But I'm getting older. My focal range is deteriorating. Now, is my head going to be in the way there? No, not too much. And this is actually borderline tricky. Might call it quits there. One of those times where my usual commitment to an excessive solder is a bad idea. You know, I normally err on the side of too much, but with this job I think I need to shoot for being right on instead. I think too much here is a very bad idea. Oh, it looks fantastic. Part of the joy of using really high quality components too, I suspect that the plastics in this socket are extremely heat resistant compared to a less expensive part. And this is the work. I did show the Zorro slot work. That one was quite thirsty, both for heat and solder. Wonder if there's something going on the other side of the board. None of these have great big thermal doobly-doos on them, at least on this side of the board. So that's the work. These chisel tips are fantastic. Thanks to Dave Jones on the EEV blog for recommending that I go to that instead of the default conical tips or the bevel tips that I honestly don't see people using these chisels all that often. I do slightly worry when I press on a pin and bend it, and as the solder's cooling the pin flicks back. I'm left with a concern that the joint might be slightly compromised. A bit of dark flux on there, a bit of crustiness. It's going famously. What lovely shiny joints, sir. And that's at this temperature that the flux doesn't get damaged, especially when I'm not putting the solder onto the iron, so it doesn't even get to the temperature of the tip. Yeah, amazing. I mean, I suspect there's absolutely no need to revisit this, but the solder disappeared through the board, which is fine. These are through-plated gold. I mean, I think some of the conventional wisdom on soldering is probably arises out of a time when clean the tip. Probably arises from a time when boards were not so good. I mean, single-sided boards. This is a single-sided board. The only point of contact between, if these traces were the only ones, the other side of the board, which is blank fiberglass, these little pads would be the only ones that provided any electrical contact to conduct electricity. And so you'd want gorgeous fillets, you know, those little concave curves on every single pin, because the only electrical contact is the one that you can see. These holes in this board are plated with gold, like a cotton reel. There's a gold plated pad top and bottom, right? And then they're plated right through. If I do a solder joint and it looks kind of flat and unfull, but I've seen the solder run, well, there's probably, instead of having just this donut on the surface to have to worry about what I have to get right, at the moment the solder flows down the pin and into the hole through the board, the connection's occurring in there too. I mean, I think the best argument for producing a nice fillet, the best arguments for producing a nice fillet on the top of a board in circumstances like these are to leave no doubt as I inspect it that the joint's been properly made. So for subsequent visual inspection, that can be important, and possibly also for bragging rights. I mean, with some components, you know, like a port or an edge connector, there might be an argument about strength, mechanical strength. I guess that might apply for a PLC socket, PLCC socket. I always forget the last C. Not too much on that one. Let's clean the tip. We're getting there now. We'll just switch over to here. Don't do too many that are adjacent at the same time. I can't see how it matters on this, but it's just a real good habit. So like the other day I made I decided I won't leave the clock battery on the board. I'll run some cables. I'll show you in a second. Off the bottom of the battery connector. And it's partly because if I had a leaked battery on this board, however unlikely a coin cell might be to leak, I would let loose my barbaric yelp and probably not stop. But yeah, they're all nicely filled. There are a couple of them that were a bit empty. Let's top them up, eh? Lucky last. So that's that. Turn the iron off. Yeah, there's this wire. This is Teflon coated wire. It's extremely tough. A bit difficult to work with. It doesn't strip nicely, it doesn't bend nicely, but for certain applications it's what you need. And I thought I'll use it here. Bit of heat shrink through a hole in the board that's not required for anything. And then I've got a battery holder on leads coming, and I can put this on the outside of the steel frame of the case, but inside the plastic fascia. And that's cool because this here is, I'm pretty sure, completely covered by the tray that holds the floppy drives and a 5 1/4 inch drive and the power supply, and getting to it's a pain. But with this holder, I was concerned that if something rested on it, it could short the battery. Can't short the charging circuit because it's disabled. It seemed unlikely, but it also seemed to be good practice to do something about the possibility that this could short on the contact underneath. And I made this fake CR2032 on my lathe out of Delrin. And I was talking before about, you know, having stuff that looks right and practicing doing it right. This is supposed to be, it's a CR2032, so it needs to be 20 millimeters in diameter and 3.2 millimeters thick. And that's how lithium ion batteries are usually described. So, or at least it's one, I think, way of describing any battery. So there are other kind of manufacturer names and other standards, but for example, a lithium cell like an 18650 or a 21700, 21700s for example might be found in some models of Tesla. It's 21 millimeters in diameter. It's only 1 millimeter diameter bigger than that, and 70 millimeters long. That's the 700, whereas this is 32 and it's 3.2. And people often call them 2170s. And I think sometimes they are called that, but I think they're properly 21700s to properly describe the length of the cell. So making this on the lathe, this didn't have to be a super precision part. I didn't even measure a cell, I just went with the spec as I understood it. Although maybe the spec says, you know, 21700 plus 0 minus 0.2 millimeters. So you can't make them oversized. And I clearly didn't want to make it oversized, so I shot for just under 20 millimeters in diameter. And according to my verniers, depending on how hard I squash the plastic, I'm at 19.99 or 19.98 millimeters, which is an excess of precision. But if I don't practice precision, when an opportunity to make something arises, then precision will always be a hassle. And in terms of its thickness, it's slightly oversized, and I've got to figure out why. My guess is that my parting off blade... No, I don't know. I mean, we're talking about, you know, it's out by, it's too thick by like 1/10 of a millimetre. Instead of being a CR 2032, it's a CR 19.99. 33. Blacksmith precision. Jeez. Anyway, I will spend some time here. I'm still recovering from a cold, so I'm not going to do anything too difficult. I'll clean the flux off the back of this, and then I'll just have another pass over the board and start to get ready to poke in the ICs.